says that fx is equals to 2x plus 3 and its domain is greater than equals to 0. And there's a gx given to us in terms of a and b, and its domain is less than equals to q, where a, b, and q are constants. The function fg is such that fg equals 6x squared minus 21, and the domain is less than equals to q. Find the values of a and b. All right, so to find fg, we will need to plug in g into f. So 2 times ax squared plus b plus 3. And fg is already given to us. It's 6x squared minus 21. We're going to expand the left-hand side and compare it with the right-hand side. Okay, now 2a must be equals to 6 since both of them are the coefficients of x squared. So a must be equals to 3. And similarly, 2a, 2b plus 3 must be equals to negative 21 since both of them are the constants. 2b plus 3 equals negative 21. 2b is equals to negative 24. b is equals to negative 12. Okay, so a and b have been found, 3 and negative 12. Okay. Next part says, find the greatest possible value of q. Okay, now let's write fg again. It is 6x squared negative 21, where x is less than equals to q. Okay, we know that the domain of fg is equals to the domain of g, or lies within the domain of g, and the range of fg lies within the range of f. Range of fg lies within or is equals to range of f. Let's take a look at fx. Fx is 2x plus 3 and its domain is greater than equals to 0. So then the range of fx is greater than equals to 3. The minimum value x can take is 0, then fx is equals to 3, and x, as x increases, fx also increases. So the range of fx is greater than equals to 0. So range of fg is also greater than equals to 0. All right. This means that 6x squared minus 21 is also greater than equals to 3. So 6x squared greater than equals to 24. X squared greater than equals to 4. Solve this equality first. We get plus minus 2. And since it is greater than equals to 4, or you may also write it as x squared minus 4 greater than equals to 0. So since it's greater than equals to 0, we have to write your final answer like this. X is greater than the bigger value. X is less than the smaller value. Now, the Q is, X is less than equals to Q. So then this would be, sorry, there's equals to sign here. Then Q, or the greatest possible value of Q would be negative 2. So from here, Q will be equals to negative 2. Okay. Part 2 is done. Part 3 is, it is now given that Q is equals to minus 3. Find the range of Fg. Okay. So for part 3, Fg is equals to 6x squared minus 21, and x is less than and equals to minus 3. We have to find the range of Fg. So when g is negative 3, when x is negative 3, what do we get here? 6 times 9 minus 21, 33. And then as x decreases, as it becomes negative 4, negative 5, negative 6, since the x is being squared, it becomes positive. and then the value keeps increasing. So this was 33. Okay, so the value keeps increasing. So the minimum value of fg is going to be 33, and it only increases as x becomes smaller than equals to -3. So fg is equals to 33. All right, the last part is find an expression of fg inverse. All right, let's write fg again, which is 6x squared minus 21, and x is less than or equals to -3. Now let's find inverse. It's going to be y plus 21 upon 6 square root with a plus minus sign. Now fg inverse equals square root x plus 21 over 6. Do we choose the positive sign or the negative sign? The domain of fg is less than or equals to -3. That means it is decreasing. So the range of fg inverse is also going to be decreasing. So that's why we put a negative sign, because of this less than symbol. Okay. So the last part is finding the domain of fg inverse. So domain of fg inverse equals range of fg, and the range of fg was greater than or equals to 33. So the domain of f inverse is also going to be greater than or equals to 33.